Good evening, and welcome to the best coverage of the Calculus Olympics. I'm Claire Miller, here with my co-host, Nick Korell.
We hope you're as excited to get these games started as we are. Let's talk to our reporter in LaPorte, Carla, who's getting ready for the games.
I'm here in beautiful LaPorte, Indiana, home of the first annual 2018 Calculus Olympics. Let's get to the events!
That's great, Carla.
Now, before we get to the games, let's take a look at the ceremonial torch lighting.
Now, let's check in on our first event. We have the football skeet shooting competition up first today. This is an electric event, several athletes competing, and it's sure to be an exciting one this year.
But first, let's take you behind the scenes with Alex Swanson.
I'm here with Alex, professional equipment manager of the 2018 Calc Olympics. So Alex, how do we prepare the targets for the skeet shooting competition?
Well, we grab the non-inflated soccer balls and we inflate them with the air pump to 5-inch radius so they are ready to get shot.
That's great.
And done. That's how you pump up a perfect target right there.
Great stuff, Alex. Now let's get to the competition.
Now, since this is the Calculus Olympics, we like to take a look into the math behind Alex's work.
That's right, Nick. We did get an exact copy of the math that they used to get those targets up to Calculus Olympic standard.
That's great, Claire. Let's take a look into that. So the first step in finding the rate of change in the volume of our target is to draw a diagram with labels and list our knowns and unknowns. So the rate of change of the volume is represented by dV/dt. The rate of change of the radius is represented by dr/dt, and the radius is represented by r. dV/dt is our unknown. dr/dt is 1 inch per minute, and we want to find dV/dt when the target's radius is 5 inches.
The volume of a sphere is 4/3 times pi times r cubed. When we derive that, it becomes dV/dt equals 4 pi over 3 times 3r squared times dr/dt. The change in the volume, dV/dt, is equal to 4 pi times 5 times 1 when we plug in our knowns. And that becomes 100 pi inches cubed per minute. And then our sentence, the target's volume is increasing at a rate of 100 pi inches cubed per minute when the radius is 5 inches.
Now that we see what kind of math goes into Alex's profession, let's take a look at the competition.
Carla, what do you got for us?
In this competition, the first athlete to shoot the target out of the air with the football will be the recipient of the gold medal.
Oh. Oh my god. What the?
Oh my!
Oh god, that was not light.
That's a good trick.
Wow, what a throw by Al. So Al is the winner of this year's skeet shooting competition. Fantastic work by all the athletes this year. But how does that competition relate to calculus, Claire?
Well, it's interesting that you asked that, Nick. We actually do have an exact copy of the math that goes into skeet shooting.
To find the area between the football and the target, we first have to draw a graph. The function h1 is representing the flight of the target, which is negative t squared plus 6t plus 4. The flight of the football is represented by h2, which is equal to 2t plus 4. The graph is height versus time. So the representative rectangle we drew is the change in time, dt, times the change in height, h1 minus h2, which is the top function minus the bottom function. In order to find the upper and lower limits of the integral, we have to set them equal to each other. h1 is equal to h2 to find the intersecting points. So negative t squared plus 6t plus 4 is equal to 2t plus 4. Set them to one side so they're equal to 0 to find the intersecting points. And the intersecting points are 0 and 4.
So to find the area between the two functions, we need to take the definite integral of the top function minus the bottom function, dt. So we plug in h1 minus h2, negative t squared plus 6t plus 4 minus 2t plus 4 times dt. When we simplify this, it comes to negative t squared plus 4t dt. And then when we integrate, we get negative t to the third over 3 plus 2t squared plus c. And when we solve that, we get 32 over 3 feet squared. So when we put our answer in sentence form, we find that the area between the function of the football and the function of the target from 0 to 4 seconds is 32 over 3, or 10 2/3 square feet.
Okay, now let's get into the calculus competition portion of these Olympics. The athletes who will be competing in this event are known for getting very competitive, so it should be interesting.
Welcome to the 2018 Calculus Olympic academic portion. What would be your first question? Your choices are derive, integrate, define, or Barry Manilow for 200, 400, or 1,000 points.
Yes, I would like derive for 400.
Okay. Derive this equation. G of x equals e to the 2x natural log of 8x. These are your choices. What's your answer?
Is the correct answer C?
That is correct.
Define for 400.
Your question is, define natural log of x. These are your choices.
Is the answer B?
Wrong. The correct answer was A. This is your last question. Anyone can answer. Barry Manilow for 1,000 points. Who is Barry Manilow's biggest fan? Dan Olson, Blake Cornett, Hannah Schuster, or Julie Welling?
Julie Welling! Julie Welling!
Quiet. The correct answer is Julie Welling.
Wow, boring.
Extremely.
Those contestants are the smartest calculus has to offer. With our games coming to a close, I'd like to thank everyone watching from home for tuning in to these Calculus Olympics.
These Olympics were tremendous. We'll see you back here in 2022 for the Calculus Olympics.